Hello, and welcome to Mavenspire's first storage webinar in 2025. And um, why that is sort of funny is that you could do one of these every year because the definition of modern storage does seem to change each year.
Yep.
Sorry, I'm like, it's such a funny thing, right? When you do a demo and you do a webinar, you're always waiting for the new and interesting tech support moment. I am waiting while my computer in front of me decides to shift all my audio devices. So this is going to be an interesting moment. But if everyone can still hear me, I assume you can because Butch, you're laughing.
Yes,
I'm going to give this a
absolutely.
shot and see if teams will hold it together.
Okay.
So it has been Mavenspire's contention for decades that when we're talking about storage, we're talking about something that is the long-term memory of your organization. This is where all your intellectual property lives, all what you do lives, all your applications live, everything that is important to your employees live. It's all on storage. And so when we're talking about storage, we're talking about the stuff that can lift you up and enable you, allow innovation, or it's the thing that can hold you back. And so today we're just taking the 2025 version of why are we talking about storage? So again, storage is where all your information lives. We are in the intelligence revolution. If you didn't know that, yeah, they've declared, and just like the Industrial Revolution, these kind of ground-shaking, huge change kind of moments in human history. We're in the one that's about intelligence. And intelligence is put together by looking at data, and data sits on storage. So when you think about the things that have limited information technology, people tend to think about memory, compute, and storage as the big limitations of performance and ultimately what you can do. So, everyone's feeling pretty good about compute, or at least they were up until people started doing things with AI. And now you can see just the craze around GPUs and custom processing to go even faster. People were feeling pretty clearly secure about memory until they needed terabytes of it every single day to do what they needed to do. Storage has always been sort of the thing that people asked for: infinite capacity at infinite speed at zero cost, like for decades, right? And this still goes on even today, right? People say we've discovered and made the fastest storage on the planet, and then the next week they say, and we made the new fastest storage on the planet. This is sort of the cycle that we're in. So just to give you an idea about why it is so hard to do storage. When the word big data was coined, this was actually in the 1990s, the total amount of storage that people were talking about was less than a zettabyte. What is a zettabyte? Something so big you don't even want to think about it, right? But the point that you need to understand is they were talking about it being super big when terabytes seemed like a lot. Since then, since the 1990s, if you just look since 2013, when they started tracking the world data sphere as a factor of zettabytes, in 2013, it was 4.4 zettabytes. So it's taken a hugely long time to get up to that number if you look at the age of information. By 2019, it was 45 zettabytes. So now we're crossing like multiples in just short numbers of years. In 2024, it was 149 zettabytes. So just an unimaginable sum. And in 2025, a year later, 200 zettabytes. So not only is this thing accelerating, we're talking about huge units of measure. So this is why we're talking about storage. Everyone is trying to figure out what they need, and how to simplify those needs, because storage is the enabler. It's not the thing you're trying to do, right? You You want to run an application. You want to build something new. You want to build the next generation castle, right? Storage is just a part of that puzzle. And it used to take way too much of the oxygen to figure it out. And now people are trying to reimagine how to do it in a much more simple way. So for the purposes of this webinar series, we've divided it up into 3 parts. We like to make each part just the right amount of time so you can consume it and understand it and have time to fit it into your busy day. The first one's going to be about block storage. That's today. This is the place where we put operating systems and applications and databases. This is the foundation of operational technology and information technology. Our next 2 will be about unstructured storage, which is about your data space, the files and objects and streams of data that are the rocket fuel for AI. And then finally, we're going to talk about backups and objects and cloud, which are the secondary storage that it's about doing availability and resilience at scale. So with that in mind, I want to introduce my partner in crime today. We call him Butch, I guess his apprentice, however you want to use yourself. It's so confusing when the name on the screen and the name you know don't match up. Why don't you intro yourself just so that people know who you are, and thank you for digging deep on block today.
Awesome. Michael, thank you so much for that wonderful and warm introduction. You know, what I love about the conversation that we're going to have today and about working with your team really is around this area of storage. For me, since 2000, I've been a part of the Dell EMC storage family. I grew up on this stuff. And every time we see an arc in the history of what's going on in the internet or compute or AI or cyber resilience, every time there's a magnificent effect on what we do with storage. And so I get excited, and I like to introduce myself as saying I'm probably the guy with 5 decades of experience building the systems that we now need to query. We now have to have questions about. So this has been my role for a long, long time. But again, very happy. Thanks for the introduction. Let's get started. When I think about the idea of this particular talk, I want to really wrap this talk around understanding what's going on in the storage world and why block storage is now back front and center. We've been doing a lot of growth in how storage is going to be used, how it's been used over in the past, and how it's used now. A lot of it really drives us back to understanding specific needs around certain workloads and understanding really that certain storage solutions really work best for very unique workloads. If you're building out a solution for high performance, we've solved that. And we'll talk about the way we solve that today. It's been in place for a long, long time. There's been a move to say we as we look across this spectrum and look at all the different capabilities and requirements for the workspace, how do we handle all of them? Which products fit best? What solutions do you need? What do you have to consider for security? What do you need to do or consider for migration? It's understanding operational efficiency, transparent costs, and scalability across the board for all of these to really understand what really, really makes sense for your clients. And so today, at the center of that, we're talking one of my favorite topics, which is the block storage revolution. Block storage is where I started out, and it is something that is near and dear to my heart. It's held that as kind of the leading way for enterprises to look at building out solutions where storage is key to it. I work with companies like PepsiCo, Frito-Lay, Baylor Healthcare, building out systems in the early days. And I also work with some folks on things like financial data and that type of thing. And what were they looking for? In every case, the storage solutions was driven by the need to have speed, of course, and also the ability to have some adaptability in the foundation. So we're going to talk about this dynamic flexibility that you get, the digital strategy that builds and just doesn't stall when you as you build it out. This is also being driven by a conversation that we've had for quite a few months since the Broadcom change of processes and policies relative to the way that they went to market with Dell, and everyone kind of revisiting some of the existing or previously held understanding of how they wanted to go to market with hyperconverged as a solution. And so, in addition to all the workloads, we've got the fallout, I guess you could say, from HCI. Um, what we found from hyperconverged was that this was like having a storage and a server kind of little data center with network in a box. Easy. You know, you buy a pizza box, it's got all the components. You deploy it out, and it takes care of all your problems, and you kind of manage them in groups. What happens that makes this more difficult is when it's time to scale. It's understanding that, you know, I need to keep a level of performance that I may not be able to keep as I start to grow these things out. And then there's the connectivity between them, and how do I design for the modularity? And then what happens if there's a change in capabilities, a new product that comes into that mix? How does it fit in with the growth that I've built? Am I now stuck on a particular software choice that I made a decade ago, thinking that at that time it really would be the best for the long term? But because of negotiations and contracts now for my business, puts me at a little bit of a risk. And so I need to be able to put something together where I get the benefits of having the compute, the networking, and the storage, but really I need to be able to scale them independently. I need to be able to measure and move them and use native tools in any way, shape, or form. And that may change from one point, you know, from one moment to the next. Enter the return of my friend, the three-tier architecture. The three-tier architecture is when I look at servers, networking, and storage separately. And I really dig in and say, which storage solutions fit best based on what I'm really trying to do? What does it give me? It gives me that independence, a lot of flexibility, a lot of power around how I want to deploy it, how I want to roll it out. I'll talk to you a bit about the benefits. I'll talk to you a bit about the migration, and then we're going to do a dig in on what the product line from Dell looks like around the solution. So we talked early as one of the benefits is, and will always be, the independent scalability. What does it mean? In the previous scenarios with hyperconverged, as an example, if I want to increase my storage capacity because it's a pizza box, I had to buy compute and network along with it. So I was really kind of stuck when I started to scale, whether it was compute or storage, as far as how I physically grew the box. One incremental growth component, you know, I could put in, you know, another terabyte of storage, and it would cost me quite a bit because I have to put in an additional set of nodes in place. Well, you know, benefit number one is being able to independently scale compute, storage, and size it specifically for what you need at the time that you need. So that's a huge benefit. And we've seen people see cost savings because they're not buying both compute and network and storage at the same time, but really very efficiently buying exactly what they need to fulfill the performance that they need. Second benefit, understanding the control and resiliency factors. When I think about this, it's understanding that resiliency is really driven by understanding that, you know, my data is going to need protection in some way, shape, or form. So there's advanced replication that's always at the core of any storage solution that we sell. Synchronous or asynchronous, or, you know, whether you have it from one to many, many to one, however you build out to protect your data, that storage system has to be very, very flexible and be able to give you an ability not only to make a copy of the data, not only the ability to fail over to a site in case of a disaster, but ultimately to fail back to a normal state. Thinking through that whole disaster recovery, looking at the geographical impact of how that's rolled out, and making sure now in today's date that you've done that, understanding if there's any compliance, if there's any things that are required from the audit trails, encryption at rest, those things that from a compliance area are necessary. Your storage system's got to be able to step up to that now. This is table stakes for everything out there. And now there's a granular level security required. We call it role-based access, where you can support multi-tenancy and multi-segmentation of storage across many, many different units. But now you control who sees what volumes and what data is available to what applications at a pretty detailed level. Then there's benefit number 3, the smarter integration of putting these solutions together, best of breed components and software that really is designed to work with these best of breed hardware components. We'll talk a little bit at the very end of this session about the Dell AI Ops solution that brings all that back together. So this is kind of the area of predictive intelligence, an area where we really start to sew that story together and make it fit for what we'll talk about over the next few weeks.
It's interesting to me that, we used to have the big debate about whether a storage array was software defined or hardware defined, right? There was that whole, does the OS on top make it software or whatever? But with the rise of HCI and seeing technologies like vSAN and such, which are clearly software defined, right? Technologies, it's been interesting how it's been a teacher to the people making the arrays, where they figure, you know what, it doesn't really matter if I'm hardware or software defined. What matters is, can I be more intelligent? Can I bring that goodness back to the goodness I had of being an array, of being a dedicated piece of hardware in a 3-tier design, and close the gap? And in the same time, the software defined people have sort of the economic shift of now being subscriptions, where one of the big things that arrays have given people forever is predictable cost, right? Because you buy it with maintenance for a number of years, and you know what it's going to cost per gig, per month, every day that you have that thing in service. But when you move to software subscriptions, the price can change year to year, and people are just now starting to catch up with, what do you do when that happens? What do you do when the economics have shifted from expectation, and how does that all play together? So it's so funny, like, we've been doing these so long, but it's who's got the benefit shifts generation to generation, who's the innovator, and who's the person learning what the next innovation is going to be. So it's just kind of funny to walk it through.
That's interesting, and I love the way you pulled that together, Michael. You think about it, this has always really been a software play. You just pick the hardware, right? So whether I did it across compute and called it vSAN or called it, something from Red Hat or whatever, I always, I drove this by features, right? And those features were around ease of operations. They were around the strategies and the steps required to make sure that system could live. And so, you bring about a great point, and I think it's reemphasized too in this next step of slides, where we talk about a common problem that people are introduced to when they're thinking about, can we go from this hyperconverged to this 3-tier, and that's what steps, what do I think about when I'm thinking about migration? This is one of the first and kind of telling areas of, do you have the right solution in place, right? We look at it from the standpoint of a standard 6 steps for everything. But the first part of that is really assessing and mapping everything that you have in a network. Now, there's tools out there like Live Optics, excuse me, that will look at the environment and help you to start to determine sizing, performance, but you still have to map application, understand the dependency. You still have to know what's critical, what can't go out. You still have to perform all of that. So there's a discovery and assessment. And then you look at the architectural design. And we talked about whether you've got data protection across geographies. You make selections as to what components of your environment should be block, file, or object. And you design networks in Fabric to support that distribution. This is an area where Maven's Fire is critical to helping customers really lean in and understand this is the best case, because they've seen so many setups and scenarios. And then, of course, the connectivity setup, understanding the SAN zoning, if you're going into the block storage, you'll move back into understanding, how to put together that fabric. And in many cases, that's either like a brocade or a Cisco type of discussion. It could be, or an Ethernet discussion, depending on how you want to, lay those things out in today's world. And then you prepare for migration, right? Understanding that the backup of everything is critical. Do I have a copy that I can go back to? What is my rollback plan? Where are my test plans that I need to put in place for the disaster recovery? All of those things all have to kind of be mapped out. And then the final data and workload migration, the real deal, moving the data over to the new thing. Usually this goes in phases. You want to be able to chop this into areas where the non-critical data may go first, the critical data may go last. Anything that fits the way you do business, your availability, all of those things have to have play with that. And the final step really is that post migration validation. This is where you really look at the baselines that you started with, making sure that you've got the right performance, you got the right, volumes in the right place, and you've optimized your network and all the paths, you're multi-pathed and to the right applications, and everything starts to fit and work seamlessly. And then your training on the back end, your staff on the back end, everything that you need operationally to keep this thing going. And that's where it really kind of brings it all home. So big breath. That's one of the first use cases for the block storage. Um, and now we'll kind of talk about some of the real things that we love, or I've fallen in love with, and easy to discuss. Whenever someone says, "Hey, I'm looking for storage," my first questions are around what do they need to do for performance? You know, how forgiving is the latency, the IOPS, the IOs per second, the direct access? What components of connectivity are needed? And this drives me to which solution might, the first step in understanding the solution. Now, these are words that, maybe, some people don't live by. A lot of people don't walk around, pulling out their IOPS tag and going like, well, I need 50,000 IOPS and I need a low latency. Most people don't talk like that. Maybe we do. Here's the real deal. What most people talk about is use cases and success stories. We've got three of them on the table, and I use the Dell product line to kind of talk through some of the questions that we saw in certain success stories, and you can kind of see where we leaned into one of these three platforms from Dell to solve specifically the block storage. In the genomic research area, there are so many changes in growth as far as like what's going on from DNA sequencing to understanding research and how that data is growing unpredictably. And then scaling storage using solutions around this is just astronomical. And so with this added uncertainty in the compute resources, on the storage resources, sometimes you need an architecture that can be very, very flexible. In this particular case, there was an opportunity for Genomics Research Lab where they were able to get a 9-to-1 data reduction guarantee. Now understand that PowerStore, and you'll see in the next slide, has a guaranteed 5-to-1 data reduction. We'll talk a bit about how we come to that reduction and how we see whether we're going to hit it or not hit it in the actual GUI. But in this case, for this particular use case, they were able to get back a 9-to-1 data reduction. That means a lot more computation gets done on a lot less space. And so this allowed them to do bigger capacity growth, 400% capacity growth with no problem. And so the results were really storage costs were reduced by 47% compared to the previous HCI infrastructure that they had in place. This now gives the ability to independently scale and enable research and accelerate without budget constraints. And so when you look at Genomics Lab, you look at Dell PowerStore, faced with this avalanche, right, of DNA sequencing data, the lab exploded and the storage needs went without, really matching compute scale. This gave us back exactly what they needed in order to shave weeks off of their analytical cycles. So the hero in this story from a block storage standpoint is the Dell PowerStore. This is one of my favorite platforms. Imagine if all of the engineers from all the different lines from Dell all met up and said, okay, we'd like to build a storage solution for the future and we need it to have, all of the best functionality from everything we've built, but it's a futuristic scenario. So we want to look for everything in our existing storage solutions that really doesn't work well. Start with PowerStore. PowerStore is a container-based operating system solution. This is important to me, and maybe one of the things that I really love about it. In prior scenarios, when you build out storage solutions, everything on a storage system is a service. Let's take replication. If I want to replicate from one storage solution to another one somewhere else, that's a component of the software, right? On the PowerStore, it's a container. If I want to update that functionality to be able to have more features or capabilities, I'm just updating a container on each of the nodes. I'm not having to put in a new service patch. I'm not having to do long, move data from one, side of the array to the other while I do these updates. I'm updating a container. I get new functionality. I check it, it rolls, and I keep it going. This is the most amazing operating environment that I have witnessed in the time that I've been there. I mentioned the 5-to-1, and this is something where people get, oh, I don't want to start off with 5-to-1 and have it come back wrong. This is a 5-to-1 reduction guarantee. What that means is if you're putting in systems like where you're just storing MP4 files, it's not going to reduce. And we know that. We're technical enough to understand that. Now in the interface in the PowerStore, it will let you know that here are the volumes with the data that don't reduce. You may want to move those over to an array where you don't have that efficiency. You can leverage the efficiency on the data that it can work best on. So this is what I sell. This is what I talk about a lot. This is the one I lead with and the one I love. I will roll from this to another scenario, to another solution where necessary, but 85% of the times that I talk about block storage, this is where I start the conversation.
Let me clarify like a couple of the terms that you used, because it's funny when you get to watch other people present, you get to understand that all of us like speak a common language, but it isn't English. So just in case anybody is not keeping up with some of this, I wanted to explain just very briefly, when people are talking about reduction, it used to be a long time ago in a galaxy far away, or at least it feels like it some days, that if you bought like a terabyte drive, assuming that was even available back then, you understood that you were going to get about 800 gig of it. Like that was what your expectation was. And it was like 1-to-1. It was black and white, right? And everybody had the same rules. And then flash disks, SSD disks came out, and if they sold you a terabyte, you got basically a terabyte, which was amazing. Everybody thought that was amazing until they saw the price. And then they didn't think it was so amazing anymore, because flash in its beginning was much more expensive than the traditional mechanical spinning disk. And so it was very quickly understood that when you went from something that spun that was a little slower to something that was a lot faster, you could insert software where you could actually make a 1 terabyte flash disk look like 3 terabytes. And this is this reduction. This is why everything's in a ratio: 5-to-1, 2-to-1, 3-to-1, right? What they're saying is physically there might be a space there, but when we actually put data on it, we can shove in a whole bunch more, which originally was all about the economics of the thing. Now, if you remember back to like my first slide, where we talk about how fast data is going, the economics of the drives have settled out over time, but we have a data explosion going on, where suddenly you need to figure out how to shove a huge amount of data on these arrays, and it's growing every year. So we've pivoted from the price of disk being the thing that everybody is concerned about to how much you can fit into something that looks like that physically. And it needs to be a really big number now. And so the software is now giving that sort of capability. So when you see something like 5-to-1, it literally means that if that box has a petabyte of space in it, you get 5 petabytes in that same box, right? And that is how we're keeping up with this data growth thing. So I just wanted to make sure everyone was super clear on the conversation. Now, some things don't work with that software, which is what what Butch was talking about, that maybe you consider where to put the things that won't blow up 5x or won't decompress the way they're supposed to. But in general, this is what's going on. The software is so good now. You know, when it originally came out, everybody was super doubtful that you'd get 1.6, 1.7. The fact that
Yes.
people will write a guarantee now on anything
Yes.
above 3 is amazing, right? And now 5 is ridiculous, right? But it's all
Right.
about keeping up with the speed. And by the way, and I may be stealing your thunder, I'm sorry. Like at the
No.
same time, the drives got bigger.
Oh
So
yeah.
two different ways to get to the same goal. You know, getting more in a smaller disk by software or by hardware. The other thing
Absolutely.
I
That
just
I
wanted to
mean, hey.
clarify for people on the containers thing is
Hmm.
with the dawn of the hyperscaler clouds, everybody fell in love with something called microservices architectures. And what they loved about it, and why you hear about containers versus virtual machines all the time now, is all going back to this one thing. When you set a goal to say that you're going to improve your application 10 times a day, which is kind of the fundamental, like, continuous change
Hmm.
kind of concept, and you start applying that to a storage array, you make a ton of people really nervous because you're messing with the data. But if you redefine how that array works so that every individual function has its own container, its own separate thing that you can patch without touching the rest of it, it really frees you to make very fast improvements. And if you
Hmm.
want to add a new feature, you're making a whole new container. So you're not affecting the ones that were already there. And that has really created velocity in going from like idea to production very,
Sure.
very quickly with arrays. And it's really closed the gap between the software defined like universe and the hardware universe of storage. Because if people can dream it, they can get it turned in just a few months, regardless of which platform you're using.
Yes.
But
Yes. That's I mean, that is so key critical. You think about it, from Dell's perspective of being able to go like, okay, we can really use this to our advantage if we're really strategic and long term. For those that didn't think it through, they're going to be, another cycle or two before they'll be able to take advantage of it. So game on, given that opportunity. This is, it's cool. I think we're driving down the same path, and I know that Michael, you love this platform as well. You guys move or talk about this and move a lot of this product, and you know, this deck really talks about that the key capabilities, but this is the one when we're thinking peak performance and we want that thing to be in a mid-sized 2U container. This is where we go. And then to add to that concept, I wanted to lean in on something else you mentioned, and that's really on those drives, right? When we look at, the NVMe drives that are in this box, there was previously the TLC, which is the triple level cell drives across the board. Recently, Dell released quad level cell QLC drives available in two of these models. And what does that do? It gives us the ability to have a more data dense drive in the QLC drive. That's a 15 terabyte drive that we can put in place for that type of a solution. Oh, with me, there we go. Sorry. To be able to put the QLC drive in place for those solutions, and we get back more capacity when we work through those systems in that way, um, as we start to build it out. So I'm going to kind of summarize to say, hey, within that power store, this is the big hero slide. This is, where the lean into the 6 areas to talk through. I have those things from, how is trusted, future proof, resilient, modern, efficient, and easy to use. There are a ton of software things that we can spend more time on. And I would love to go do deep dive on that. This is an area where, when you say this is an area that we want to go in that direction, we've got a ton of collateral, et cetera, to kind of build that out.
there's
Next
a
up. Mhm.
it's funny. Mavenspire was kind of there when they built PowerStore. We were part of the beta program. We were part of, and many people know that the technology came from a consolidation of multiple products that used to be necessary or used to live in the Dell EMC universe. And there used to be sort of this meme graphic running around where they talked about like the old world and the new world. And the old world had like, it was a picture with like 1,000 dials on it and switches and whatever. And the new world was a picture with one button, on and off. Right? When they built this and they gave it the intelligence it has, I'm not going to try to claim that it does everything automatically, but just the base level intelligence on this to see what's going on and adapt to the situation on the ground is just so different than what you would have in an array even 10 years ago. It's just crazy.
Oh.
And the fact that,
yeah,
it's not just about how many slots you can put in the front, but the fact that you can take multiple of these and group them together in clusters and stuff.
Yes.
It's all the goodness of watching how people actually use this in the world, just getting pulled together into one platform. It is, as you said, it's amazing. And it's just so easy to be able to say, I hear what you need to do today. I got you.
Man, yeah, this is crazy. So yeah, great, love it, love the summary. This is and it's running across 90% of the Fortune 500 sectors have put this thing in. I mean, unbelievable over the last 3 or 4 years, growing like crazy. Let's pop into another use case. We'll go through three of them. This is the second one, and I'm a fan of the software Salesforce. Company is based in Indianapolis, where I grew up. And so I was a fan when I saw them take an office downtown around Monument Circle. Here's what Salesforce does and what they've really been very thought leaderish in how they build out their customer relationship management. Everybody's, pretty much familiar with what they do from a corporate standpoint. But what you may not realize is behind the scenes, how do they support that, the growth and the different things that they put in place? For them, this is a solution that cannot go down. And whenever there's an opportunity where we have a solution where it's the data has always got to be available, it's got to be an active portfolio or an architecture with a zero RPO, that's when we look at a specific solution that'll fit that. So we use the PowerMax in this case. It supports up to 65 million snapshots. I'll say that again. The PowerMax supports up to 65 million immutable snapshots. That's unheard of. So this is data protection and forensic capabilities that are far beyond any of its competitors. Active configuration, of course, eliminating all the single points of failures. 7 nines regarding the Salesforce implementation, and this gives you back everything that you can imagine from a software perspective. This has been a leader in the sector. This is what NASA uses, government, all of the stock market, everyone in that space. This is what they go when they're looking for a solution. So, we like it because it's the ultra high end. It people will ask you for the PowerMax. You really don't. It's not like you have to really look too far. They'll say, hey, I'm looking for storage, and PowerMax is really exactly what I need. I want to be able to sleep at night, and I want a job when I wake up on Monday, and I don't want to be in the office on the weekend, worried that things were not going to go well. How did it get here? It started off back in the early days under Symmetrix line. The PowerMax grew out of a back end that says, okay, let's build out a solution that's trusted, and originally something that was designed to work with IBM disk. So it was the disk that worked on mainframe compute, right? And it grew, each evolution getting smarter, then adding the ability to do open systems in addition to mainframe and 400. And then, adding more capabilities as needed, right, to support the new workloads that we talked about in the front end. But again, just building back out. It's an industry best 5-to-1 data reduction guarantee on this one, you see when you see these things go out the door, I'm reminded of the history of where they come from, how trusted they are, really across the industry, and this is based on just years and years of testing. This comes in two models: the 2500 the 8500, small to large. And, when you think of all the capabilities, this is kind of that hero slide that brings it all together. An architecture that scales from 2 to 16 nodes, 18 petabytes of effective capacity, 256 front end ports. This thing can be massive and scale out like crazy and replicate in ways that, still boggle my mind. So, any thoughts on this one, Michael?
I mean, you kind of said it. It's the gold standard. I mean, 18 petabytes in an array that can work with mainframe technology in the most demanding environments in the world, and
Yeah.
and also, over time, also has evolved in terms of automation and such.
Yeah.
That's also really, really great for environments that have to be able to like hash out and divide across multiple customers, like to be able to
Yeah.
be able, one of the few products out there that literally can set up, I'm giving you this much performance and this much space, and I will deliver that every day, even other people going on around you. um,
Right.
this
Right.
is sort of the gold standard for that too, and which is great in research with AI, where you have to be able to say, like, I'm going to be running this run, and it's got to be this good for the
Yeah.
duration of
Yeah.
that task. So yeah, like amazing stuff, and truthfully, the fact that they make a kind of a small and a large means that a lot of people think that because it's Power Max, which again, gold standard sort of enterprise sort of product. I have a lot of mid-market customers that have the smaller one for the stuff that just
Hmm.
has to be perfect. And then they fill around it with the PowerStore, which doesn't have to have the same level of unbreakable, but is pretty unbreakable for everything else. And it makes an
Yep.
amazing combo.
Yep. Yep. So we're still seeing a lot of these things go out, and the cyber resiliency thing seems to be the key to a lot of that. Um, I'll move over to the third use case. And in this case, we're really talking about a mid-sized 200-bed hospital. And they were faced with really trying to build out a solution that would support their health records, their PACS, imaging, all of the applications that they would run on the back end. But they didn't have a big budget for storage. And so looking for a solution, a lot of the solutions that we talked about will support it. But on the lower end of the spectrum, from a cost perspective, the Power Vault is a solution that fits best. Now, the Power Vault, has been around and part of the Dell portfolio for quite some time. It delivers high availability. It's got simplicity. It does tiering in a pretty unique way, so that data that all comes onto that thing gets tiered into very performant drives, and that then moved into the drives that can be kept for longer term. Um, with this solution, they were able to get a 99.9 uptime and a 40% cost savings and 60% faster deployment while pushing this out. So when you're in a cost sensitive but still mission intense environment, this hospital found salvation with this simplicity. Dual controller. They used it with Veeam integration for their data protection. And I always ask when deploying storage, how are we going to protect it? We'll talk about that a little bit on our third session, but this is something that you always want to look at is which way you want to go for that data protection. And so this was what they did for that solution. So I wanted to bring that in and just kind of talk about, when people move into the Power Vault, what are they thinking? This is something that will go up to 8 petabytes, so it scales quite nicely if needed. It is a block only solution. It does do replication, give you some of the basics that you really would have with a mid-tier storage solution across the board. We see where it may fits. There's a lots of white papers on what components and what softwares integrate very well, but this is an SMB friendly price, but still an enterprise class storage solution. So it gets the business done. It gets it done at a low cost, and this really, when I think about getting units out the door, by far on the smaller side, we see these things going out like crazy. Um, Again, same thoughts. This thing has been growing over time, continues to grow, will continue to have new features and functionality. but it will still be a part of the product line because at the low end, sometimes that's just all you need, right? Yeah.
And it's interesting that so, you know, in the case of Dell Technologies, they use these terms that are actually brands. So I don't know if people understand that.
Hmm.
So PowerVault isn't a specific product; it's a brand of product, right? And so one of the things that sometimes happens is that people don't understand that they have generations of the product. So
Mm.
in this particular case, I think we're up to ME5, generation 5 these days. And whenever they do a new generation, they look at what is the state of storage. Like what are the things that just have to be there that everyone assumes are there? And they build that in. So a Power Vault from like 20 years ago, they just wanted some disks to like spin together and connect to like multiple servers at the same time. That was the table stakes, right? But when you look
Yeah.
at like this generation, you're talking about something that can move as fast as Flash, something that has the intelligence to do replication, the intelligence to do some occasional snapshot. Like there's all of these things that used to be the gold standard in the enterprise for storage arrays are actually built into the small model now, right? It's
Yeah.
it's the the bar is raised on what is the new norm for upmarket or the more complicated thing, and it's all in sophistication of software
Yeah.
or
Yeah.
in redefinitions of the word fast, right? You don't see
Hmm.
like slides like this talking about NVMe to the node or anything like that, but it's so much built in now that everyone just takes for granted that honestly makes me want to like tell old stories about going to bulletin boards to get firmware updates. Like it's just night and day. But it
It,
doesn't
yeah.
surprise me at all that a lot of people find that if you just need storage and it needs to work and it needs to work fast, that
Yeah.
Powervault is
Yeah.
sometimes that answer. If you don't need any other sophistication than that basic need, there you go.
Yeah. That's where it actually all fits. So, man, this is great. We've kind of walked through the technical landscape of the solutions. And I think as we talked through, we talked about some of the thoughts of how to pick and deploy what, but there's, standard myths still that need to be debunked. And when you think about three-tier being complex, nope, now it's become very software driven and almost in many cases much easier to implement and to drive that out. Sometimes people think hyperconverged is always cheaper, but realistically, when you're scaling or you have concerns about growth connectivity or even staying with a particular software brand, not always cheaper. And then the block storage is legacy, not even close. It's not just coming back, it's coming back with a vengeance. And it's because it's always been proven to be, a great next step for growing out infrastructures across the board. So when three-tier makes sense is when you've got unpredictable growth or diverse workloads, or you've got strict compliance considerations. These are three areas that when I hear people or clients talk about these areas, that's when I start to think about, maybe we need to lean in and work specifically with a three-tier and maybe specifically one of the block solutions that we talked about. We talked about the store, which is the all flash flexible one, the Power Max for mission critical, and the Power Vault for the cost effective. This is really, in summary, kind of, the use cases and the things that I've seen that drive, what's next or what the next best thing is. I'll lean into one last thing as we kind of close the thing out and just say that when you have storage of any type from Dell, uh, you want to be able to have an environment where you can see and query and understand how it all works. There's a very simple Dell AI Ops software that queries all of the Dell boxes, whether it's storage, whether it's servers, and gives you back, real life metrics on your phone, on your tablet, or on your workstation, so you can see proactively where you're doing in cybersecurity alerts. And it also now has recently added its ability to have an AI ops assistant. What does it mean? I can ask questions of my array to determine, well, how is it doing? Am I doing it correctly? And it's looking back at these 133,000 plus knowledge base articles and reference manuals that are listed in there for support so that you can ask questions and get answers and how to really grow out and build that environment. When I see this and I look at the types of questions that's asked, I can say, how much available capacity will my PowerStore have in October 25? So it can look at the drives and kind of make some estimated guesses. Or I can list all the PowerEdge hosts currently accessing data on a particular PowerStore. Very, very useful and helpful as far as how do you build out something that you can trust long term. So, no conversation around storage really is complete without understanding what are we doing on the software side to protect to support operationally, and also what do we do with the data for a data protection, which we'll talk about in our third session. But the key sessions today, there's only three. It's a strategic evolution to build operational efficient agility, and the understanding the architecture and the foundation of that are extremely important in how you make these choices. If you scale this correctly and build it and think block as a part of your stored solution, this is where you get the most adaptive, most predictable foundation to build out, a solution. In our line of work, we don't just ask what's new; we ask what's inevitable, and that's when we lean into the block solutions that make sense. And once again, we do this with Maven's Fire because these folks know exactly how these things should be deployed. They've been doing it for quite some time, and one of the best partners that we've ever worked with. And so I think having that wonderful trifecta of the Dell product with Maven's Fire's hands and minds around it gives you confidence that you're doing the right thing, and you're building an infrastructure that's not background but scaffold, and you're building something that's going to actually allow you to dream bigger and build apps that allow you to run into the future. The future that you're building really is it's got to be block ready. This is the way to get it there. That's all I've got.
Thank you so much for walking us through that.